All right, here we go. I'm gonna also do this. Okay, so today we're gonna start talking about random variables, okay? So the first thing that I want everyone to do is in the chat, I want you to count up how many siblings you have, including half step, all those things. And I want you guys to type in how many siblings you have, including yourself. So include yourself as a sibling. Include yourself, remember. Okay, in the chat, what we're doing right now is we're including ourselves and we are counting how many siblings we have, including yourself. Yes, going forward, you're not going to be in the chat, but right now I need your data, so go. Include yourself as a sibling, include all half siblings and step siblings. All right, so I'm just going to do a quick tally. So I've got a 2, got a more than 6, I've got a more than 6, I've got a 4. And remember, you're including yourself if you have not yet given me your data. 5, 4, 5, 4, 5, 3, 1, 3, 6, 1, 1, 3, 6, 1, 5, 5, 3. All right. All right. I'm just going to use the data that's in there so far. I tallied it up right here. So I've got 2 people with 1 sibling, 1 person with 2, 3 with 3, 2 with 4, 4 with 5, and then we got 3 people with 6 or more. Okay. So what we're going to quickly do is we're going to find the probability of choosing somebody in the class. Remember probability back a couple units. Okay. Of choosing somebody who has each of these siblings. Okay. So I'm going to put my calculator right here for you guys so you can see what I'm doing as a review. Okay, so we have 2, 3, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 pieces of data. Okay, so the probability of choosing somebody with 1 is 2 out of 15. Okay, so that is a 0.133 probability. I'm just saying the decimal. Okay, probability of picking 2 is 1 out of 15. Okay, and that's a 0.067 probability. Okay, 3 out of 15. That's a 0.2% or 2 probability, not percent. 2 out of 15. Okay, that's another 0.133 probability. 4 out of 15, that's a 0.267 probability. And 6 or more, that's 3 out of 15, that's a 0.2 probability. Okay. So the first question I'm going to ask you guys is this categorical or is this quantitative? So quantitative is just a fancy word for number. Categorical is something that is a category, okay? This guy right here is going to be quantitative. Quantitative, okay? Why? Because it's all numeric values or numbers. Okay, if you guys have an immediate question, feel free to just talk it, okay? Okay. So are all the probabilities between 0 and 1? Are all these probabilities between 0 and 1? Yes, they should be, right? We're not talking about percents. We're only talking about decimals. We're never going to have a bigger than 100% or 1 probability, okay? When you add all these numbers up, we want to know what we get, okay? I'm not going to show my work, but I am going to show my work using my calculator here, okay? So we've got 0.133 plus 0.067 plus 0.2 plus 0.133 plus 0.267 plus 0.2. When we add up all of our probabilities, okay, we get 1, okay? Reason being, we are going to pick somebody who falls into one of these categories. There's no other categories, there's no other data that falls outside of those. So the probability of picking anybody is a 100% probability, or 1. Okay, so X was our number of siblings up here. Is it possible for X to be 5.7167? No. You can't have that fraction of a sibling. Okay, we're going to talk about what that means in a second, okay, what it means when you can't have certain values, okay. Describe in words what P, I'm going to write this a little bigger so you guys can see what it says. P of X greater than or equal to 3 means. So what this means is the probability of choosing a value that's 3 or bigger. Okay, and how we get that is we're going to add up all of the probabilities of being 3 or more siblings. So if we add these numbers up, okay, we're going to add, oops, not that. This way I'll get together. All right, we're going to add 3 or more. So we've got 0.2 for 3. We've got 0.133 for 4 siblings, 0.267 for 5 siblings, plus 0.2 for 6 or more. So there's a 0.8. 0.8 is the probability of 3 or more siblings. This question is similar, but it's slightly different. What this says is P of X greater than 3. Does anybody want to say how these two things are different? What's different between these two? Anybody know off the top of their head?
Try to say that one more time. Sorry.
What's the difference between these two probabilities?
That one is greater than 3. The other one is 3 or more, right?
Good. So this guy right here is greater than or equal to 3. This one's greater than 3. So the only difference between these two is when we find our probability, we're not going to include 3. We're just going to do everything bigger than 3. Okay? Bigger than 3. Okay? So again, we're going to add up all the probabilities that meet that. Why do I keep doing that, Miss Whitehill? Get it together. That meet that condition. Okay, so 4 is 0.133 plus 0.267 plus 0.2. So there's a 0.6 probability of being greater than 3. Not greater than or equal to, not including 3, but bigger than 3. Okay? So let's say that Y is the number of time in minutes it takes to randomly select student to run a mile. Is 5.7167 a possible value for Y? Well, in this case, it is a possible value for Y. Reason being, you can have fractions of time. Okay, you can't have fractions of people, but you can have fractions of time. Okay, does anybody have questions on anything I've gone over so far? I'm just gonna quick check the chat in case anybody has any questions that they posted. Geez, guys. Okay, so this is gonna bring us to the last part that we're gonna go over, the questions you guys are gonna work on independently. It's today's assignment. Okay, so some important ideas. Okay, so for a probability to be a valid probability, okay, so validity, this comes when first all probabilities are between 0 and 1. It's not valid if they're not, because then it's either way too possible, right? Over 1 would mean that it's over a 100% probability. Okay, and 2, all, I just want to make sure I write this right. Probabilities add to 1. Okay, and we saw that on the front when we had our data on our sibling counts, all the probabilities added to 1, and there was no set of data or single number of siblings that had a greater than 1 probability. Okay, second idea, probability of X greater than 3 is different than the probability of X greater than or equal to 3, and we talked about those two things. Okay, and the last thing is discrete versus continuous data. Okay, if something's discrete, does anybody know what that means? Okay, so discrete just means that it's a fixed values that has gaps. Okay, and that's like the number of siblings. Okay, the number of siblings had gaps because we can't have fractional number of siblings. There's holes in the data set. Continuous is just all possible values with no gaps. And this would be like time. Okay. Okay, so discrete continuous, your data is either gonna be one or the other. Okay, you cannot be both discrete and continuous. Okay, does anybody have any questions on anything that I've gone over? I'm gonna stop recording this.